Okay, so I'm not sure what happened at the end of lesson 1, but it cut me off before I finished the problem. So we're going to pick up where we left off, and this is lesson 1b, and it trails lesson 1. We're in the middle of making a solution. So we were talking about making a 0.1 molar barium nitrate solution, and I needed 500 milliliters. And we were in the process of calculating the number of grams that I would need to make this. So we started with 500 milliliters, and we were converting it to grams. So we said 1 liter is 1,000 milliliters, so milliliters canceled, and we said that the molar concentration of 0.1 molar is really 0.1 moles per liter, so we use that as a conversion factor here to get liters to cancel, and then 1 mole is equal to 261.3, and that was grams of barium nitrate. I didn't have enough room to write that there, so my moles would then cancel. So 500 times 0.1 times 261.3 divided by 1,000 is going to give me 13.065 grams of barium nitrate, and we would be fine just using this as 13.1 grams. So what's the next thing I would do? Well, I would take a small amount of distilled water in a volumetric flask, and then I would add the solid, the 13.1 grams, swirl, swirl, swirl until it's completely dissolved, and then I would fill it up until I get to the 500. So in this, they just put the dry in the bottle. You can do it that way. They put the solid in and then add some water, swirl. I like to put a little water on the bottom and then add the solid so that it doesn't stick to the bottom. Sometimes when you put, like when you're making Nestle Quick and you put the powder in the bottom of the glass first and then put the milk on top of it, sometimes it all doesn't dissolve or you have a difficult time dissolving it. So if you put a little bit of water in there first, it kind of makes the dissolving process go a little bit more smoothly. Okay, what about if we're taking two liquids and mixing them together? Maybe I have to take hydrochloric acid, okay? And hydrochloric acid comes as a 12 molar concentrated stock solution in the bottle when we purchase it. And maybe I need 250 mils of 3 molar HCl. So in this instance, we're performing a dilution of a liquid as opposed to making something from a solid. So we talked about this in our inquiry lab this week. We're going to use the dilution formula M1V1, which equals M2V2. Molarity 1 times volume 1 equals molarity 2 times volume 2. So essentially, let's write down what I know. I know that I have an M1 of 12 molar. I don't know how much I'm going to use of that. I know my desired result is going to be 3 molar, and I know that I'm going to need 250 milliliters of that. So in solving for V1, I get 62.5 milliliters. So that's the volume of the 12 molar HCl that I'm going to need. So what I would do, instead of a 500 milliliter volumetric flask, I would get a 250 milliliter volumetric flask, and I would measure 62.5 mils of HCl. I could use a Probably the most accurate would be to use a bulb pipette, and we have some pretty big bulb pipettes. We have, I believe, up to 50 mils. So you could use technically a 50 mil and a 25 mil pipette and get your 62.5 mils, put it in your 250 milliliter flask, and then basically add distilled water until it was up to the line. And that's it. That's all we had to finish up on this. Okay, look for lesson 2 where we start getting into some reaction stoichiometry.